So for combinations, this is when the order doesn't matter or isn't really important. We're just trying to find a number of combinations to order these things. So for combinations, we will use NCR. And again, you guys can use the longer formula here, where it's the number of possible objects that you're choosing from factorial over the number you're choosing of the total times the difference between the two factorial. You can use that, but it's really just NCR or N-choose R in your calculator. So if there are possible 59 numbers and the lottery officials draw 6 numbers, it's asking how many possible combinations are there for 6 of the 59 numbers. So all we do is say, okay, 59, choose 6, and that's going to give us 45 million combinations. This is why no one wins the lottery. So 45 million, 57,474. Different ways to make a 6-number value out of 59 numbers. A college football team plays 10 games during the season, and how many ways can it end the season with 5 wins, 4 losses, and 1 tie? So this is where we have to sort of use our critical thinking. We can't just quickly run through it. We have to think about it a little bit. So we start with 10 games. So of these 10 games, we're saying 5 of those we're going to win. Okay, now we're going to multiply that by the 4 losses. So we won 5. There's 5 games left. So of the 5 remaining games left that we didn't win, 4 of those 5 we're saying are going to be a loss, or we're going to lose. And then the last game, so we've got 5 plus 4, that's 9, we need 10. So, of the 1 remaining game left, we're going to tie. So 1, choose 1, left to tie. So you would have to do those 5 values in your calculator. So 10 choose 5 times 5 choose 4 times 1 choose 1. And you can do them all together. I would just maybe put them in parentheses as you're multiplying them together, but you get a total of 1,260 ways that it could end with those specific numbers. 5 wins, 4 losses, and 1 tie. So Mr. Jones owns 4 pairs of pants, 7 shirts, 3 sweaters. How many ways can he choose 2 of the pairs of pants, 3 of the shirts, and 1 of the sweaters to pack for a trip? So we'll do the pants first. So he wants to choose 2 pants. So 4 choose 2. And then times the shirt, which he wants to choose 3 of. So 7 choose 3. Times the sweaters, which he wants to choose 1 of. So 3 choose 1. So you end up with 630 possible combinations for those outfits for him to wear. The general manager of a fast food restaurant chain must select 6 restaurants from 11 for a program. So how many possible ways can this selection be done? So it's just as simple as 11 restaurants, we're choosing 6 of them. That means there's 462 ways to choose from those 11 restaurants, just 6 of them. Number 5, it says your friend is having a party and has 15 games to choose from. So there's enough time to play 4 games. So in how many ways can you choose 4 games to play? So 15, we can only choose 4 of them. That gives us 1365. So 1,365 ways to choose 4 of 15 games. Number 6 says you must take 6 elective classes to meet your graduation requirement for college. So there are 12 classes that you are interested in taking. So how many ways can you select your elective classes? So we have 12 to choose from. We need 6 of them. 12 choose 6 gives us 924 ways to pick our possible electives. Now, for the card ones, it does give you a visual sort of there. I do have slips up in the front if you guys want to look at those as well. But it says a standard deck. So a standard deck has 52 cards. It has 4 suits. So the spades, the king, or the hearts, the diamonds, and the clubs are your 4 suits. And each suit has 13 cards in it. So if the order in which the cards are dealt is not important, how many different 5-card hands are possible? So if we're just picking any 5 cards and there's a total of 52 in the deck, we can just say 52, choose 5, which gives us 2,598,960 possible 5-card hands. So that's a good many. So letter B says, okay, and how many of these hands are all 5 cards the same suits? And remember, suits are like the spades, the hearts, the diamonds, and the clubs. So we first need to specify that of the 4 suits, we only want 1 of them, so that's the suit. And then once we've picked from just the single suit, of the 13 cards within the suit, we want to pick 5 of them. So the 1 suit times the 5 cards we want from that suit gives us a total of 5,148. Combinations to get us 5 cards all of the same suit. Number 8 says, William Shakespeare wrote 38 plays that can be divided into 3 genres. Of the 38 plays, we have comedies. 18 are comedies. 10 are histories. And 10 are tragedies. So it says how many different sets of exactly 2 comedies and 1 tragedy can you read? So combinations for comedies would be 18, and we only want 2 of them, times comedies, or times the 1 tragedy, there's 10 of those, and we want 1 of them. So 18 choose 2 times 10 choose 1, and you get 1,530 possible sets. Different possible sets of at most 3 plays to read. So just be paying attention to your wording and just sort of think through it a little bit. For 9 and 10, we're looking at cards again. So for number 9, it says, what is the possible number of hands that you guys could have if you want 3 black cards? So first, remember how many black cards are in a deck. If it's split down the middle, there's 26 black and 26 red. So we've got 26 black cards, and we want 3 of them. So there's a total number of 26 possible hands with 3 black cards in them. 2 aces and 1 other card. So, and we're just looking at 3 cards. So 2 aces. So we have 4 aces in the deck. We want 2 of them times 1 card from the remaining cards that are in the deck. So the remaining cards are not going to be aces. So 52 minus 4, because we don't want to include the aces, leaves us with 48. From those 48 remaining, we're going to choose 1. So we have our 2 plus 1 gives us the 3 card hand. Multiply them together and get a total of 288 hands that would have 2 aces and 1 other card, we don't care what it is, in it. So find the number of possible 5 card hands that have 3 of one kind and 2 of a different kind. So of a kind would be like, 3 of one kind could be like, you would have 3 sevens, and then 2, say, queens. That's what of a kind means. So 3 of one kind is going to say, since it didn't specify what you're choosing from, you have to say, okay, we're going to choose 1 of the 13 cards in the deck. There's ace through king. Of those 13 cards, we're going to choose 1 of them, say the sevens, and of the 4 sevens in the deck, we want 3 of those. So that could be your sevens. And then we're going to multiply that by the 2 of a kind. So we need to pick 1 of the 12 remaining, because we've picked 1 kind already. So that means there's only 12 there now to choose from. And of those 4, say, queens that we're choosing from, we only want 2 of them. And then we just multiply it together and get 3,744 possible hands with 3 of one kind and 2 of a different kind.